All right, next up are amides. And amides, we have a carbonyl, and then we have a nitrogen with two R groups. Sometimes these R groups are hydrogens, sometimes they're other alkyl chains or phenyl rings or something like that. And so again, we start off with kind of our best molecule, the acid chloride, and then all you do is add your nucleophile, right? In this case, it's going to be some kind of amine. You do need to use two equivalents for this amine. The second equivalent is to just soak up any acid that's formed. And again, these R groups could be alkyl chains or they could be hydrogens. You can do the same reaction with acid anhydrides and esters, but they're not as useful because A, they're not as reactive, and then B, they form more side products. So it's generally best to just go straight to the acid chloride. The cool thing about amides is that they can do polymerization. So one of the most popular example of this is nylon 6,6, which we'll hopefully be able to synthesize in lab. So you guys will actually get some cool experience there. And it's a very fun, common lab done in OChem. And so what we do here is we take our acid anhydride, or my bad, our acid chloride, and then we add our amines to it. And the reason why it's called nylon 6,6 is because if you take a look at both of these compounds, they both have 6 carbons. 1, 2, 3, 4, 5, 6. Whoops. Now they both have 6 carbons. And then basically what happens is this amine condenses with this acid chloride to form a bond, and then it goes on and so forth, right? This one bonds to another one, and then this amine bonds to another one. And so you can see you can grow the chain into as long as you want it, and depending on growth conditions, you can get different properties. Same thing, esters can do the same thing. So most of you guys have heard of polyesters, and they're just as the name implies, many esters, right? So what you do is you take usually a carboxylic acid in this case. I'm just going to call this center group some kind of R group, and then you take some kind of alcohol, and then they link together with one another. This is how Kevlar is made. So Kevlar is a polyester, and then of course a lot of clothes are polyesters. These kinds of polymers are known as step growth polymers versus chain polymers. Think back to when we formed our polymers with the radicals. In that case, we had one molecule being reacted with another one that caused another one to be reacted, and so on and so on and so forth. And these ones, we can grow each step of the polymer independent of one another. We don't really need any initiator or anything like that. Overall, polymers, very cool, but not something that we're going to cover in depth in this class.